All right, I appreciate your patience. I'm trying to save paper this year. We have copier limits. So your 3.3 handout was really... So I'm trying to save paper, guys, this year. We have copier limits and paper limits. So your 3.3 handout was really 5 pages long. But the 3.6 handout is 1 page long. So I took the last page of your 3.5 and I put it on the back of your 3.3, and I put it on the back of your 3.6. So this is that last page up here. You see rules for differentiation. We're talking about second and higher derivatives. So all this really means, we're talking about a notation for this. But the idea isn't super spectacular. A function, f, we've now learned some of the ways we could take the derivative of f. That derivative we might call f prime. And f prime is itself a function, which means if I wanted, I could take its derivative. The derivative of f prime is called f double prime, or we could also say it's the second derivative of f. So here's all right, so here we go, and you can kind of see that your handout has all the different notations you might use. If y prime is the derivative of y with respect to x, we sometimes say it's the first derivative of y with respect to x. We could take the derivative of y prime and get what we call y double prime, or d squared y dx squared. Now we say that squared, but it's not like there's any squaring, not in the sense that you're going to take something and multiply it by itself. But that's how we would read this notation. Either the second derivative of y with respect to x, or d squared y dx squared. Notice it's the same as taking the derivative of dy dx is the same as taking the second derivative of y. You could, if you got excited, take the derivative of a second derivative. That would be the third derivative. You can see from your other handout what the f prime notation looks like. So here, the derivative of f is called f prime. The derivative of f prime is called f double prime. The derivative of f double prime we might call f triple prime, or just the third derivative of f. Once we get up to the fourth derivative, and don't worry, you're not going to spend any time in this class finding fourth derivatives, but if you wanted to know the notation, after the third derivative, we don't keep making those little hash marks anymore. We actually write the number 4 in parentheses. And then here, the nth derivative, again, it's not that you're going to spend time taking that many derivatives of the same function, but there are sometimes sort of theoretical questions that they'll ask on the AP test, where you imagine what it would be like if you kept taking the derivative, because we're going to see other functions whose derivatives, when we take them, they form patterns. So that's why you just want to know this notation. This here, with the n in parentheses, that just means the nth derivative of y, or the nth derivative of x. Let's try a little example. It might be the case, since I was trying to save paper, remember, that I might have asked you a question from the 3.3 section that has these higher order derivatives on it. And now you can just go back and finish it up. Let's do this example. So this is find the fourth derivative of this polynomial function. So negative 5 times x to the 8th plus 2x to the 6th. So it would have been way more convenient. In fact, I'm going to make this change right now for next year's class. It would be way more convenient if I had given this expression, this function, a name. So I'm going to do it here, just so you can see how the labels work. So I'm going to say that this original function, I'm going to call it y. You could call it f of x instead. It's not a super huge deal. Because I want you to see what it looks like as I label my work as I go. So if this original function is y prime, I'm going to start from the left. I'm going to bring that 8 down to the front to multiply. So that's going to be negative 40 x to the 7th plus 12x to the 5th minus 27x squared plus 32. The second derivative is going to be the derivative of the first derivative. So that should say y double prime. Didn't come out really well here. Y double prime. That's going to equal the 7 is going to come down to multiply the negative 40. So negative 280 x to the 6th plus 5 times 12 makes 60, x to the 4th minus 54x to the 1st. The derivative of 32 is 0, so there's no, the 32 doesn't show up in my second derivative. My y triple prime, or the third derivative, okay, that's going to be negative 6 times 280 x to the 5th plus 240 x cubed minus 54. You can use your calculator to do that, multiplying 6 times 280. So the fourth derivative I would call, that's a y with a 4 up in there, and it's not really an exponent, so I put it in parentheses to show that it means a little something different. The fourth derivative would be negative 5 times the 6 that's there times the 280 times x to the 1 less exponent, so x to the 4th, plus 3 times 24, that's 720 x squared. So the fourth derivative of this original function is equal to whatever negative 5 times 6 times 280 x to the 4th plus 720 x squared. Final answer. All right, let's take a look at this guy down here. I'll leave that example for you. You're going to have to be a little bit careful. You're going to need the quotient rule. And then I'll do this last example. Find the fourth derivative of x. Oh, if I know the fourth derivative of x, find the fifth derivative. So, get back to here. I'm doing this problem, but I'm going to come do it up here where I have room. The fifth derivative of x, which I'm going to call f5 of x, is equal to, well, let me rewrite my fourth derivative. That's 2 times x to the 1/2. The square root of x is the same as x to the 1/2. So my fifth derivative, I'm going to get using the power rule. This 1/2 is going to come down and multiply the 2 that was already there. And now x is going to get an exponent that's 1 less, which is negative 1/2. So the fifth derivative of x, I'm just simplifying the notation I have. I'm not going to make any more changes. I'm not going to do any more functioning on this result, but the 1/2 and the 2 multiply to make 1, so I could write x to the negative 1/2. That's exactly equivalent to 1 over the square root of x. Cool, so the fifth derivative, 1 over the square root of x, or you could have left your answer like this, that's just as good. So this assignment you already did with your 3.3 notes.